Broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we should have about 10 or 15 minutes near the end of today's webinar to go through those audience questions. And finally, at the end of today's webinar, we are doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our two lucky winners. All right, with that, we'll kick off today's webinar, which is the imperative for visibility into cloud-native web services traffic. Our speakers today are Doug Coburn, who is Director of Professional Services at Signal Sciences, and he's being joined by Alfred Chung, who is Senior Product Manager at Signal Sciences. Gentlemen, thank you so much for joining me today. I really appreciate it.
Thank you for having us.
Awesome, awesome. Okay, well, Alfred, I know you are going to get things kicked off, and I know you have a great presentation on tap, so I'm going to put myself on mute and let you get right to it.
Great, thank you very much for the introduction. So hello, hope you all are doing well, and thank you for joining us for this talk. As was mentioned, I'm a product manager at Signal Sciences, so I've been working in product in the security industry for about 8 years or so now, working on endpoint security, vulnerability management, and application security testing technologies, and happy to be co-presenting today's talk about visibility into cloud-native web services traffic. Doug, do you want to add anything about yourself?
Yep, I've been doing a mixture of things, including security, functions as a service, and endpoint management for about the last 15 years. So it's an area that I have a lot of passion for.
Great, thanks, Doug. Okay, so let's jump in. Start with the agenda. So first, we'll just kind of review what cloud native actually means and kind of what the current definition of it is and how is it impacting organizations. Then we'll talk a bit about cloud native development patterns, the technologies that are typically used for cloud native applications. And then we'll jump into security and visibility into EastWest Traffic with next-gen WAF. So with cloud native applications, there are some unique security risks that we're going to be discussing, as well as ways that you can manage those risks and protect your cloud native applications. And then finally, at the end, we'll wrap up with some Q&A. So defining cloud native and its impacts. So this definition of cloud native comes from the Cloud Native Computing Foundation. They keep it up to date in their GitHub repo. Cloud native as a term has kind of evolved over the years, but lately I would say that that the industry has kind of come to a pretty standard pattern of development that defines cloud native, and that typically means the use of containers, service meshes, microservices, immutable infrastructure, and so on. A cloud native application doesn't necessarily need to take advantage of all of these technologies or patterns, or maybe just some. But we'll go into some of the specifics in terms of what makes an application cloud native versus just, say, cloud hosted. So what's driving the adoption of cloud native? Why is cloud native such a thing these days? And of course, it's change. So we all are aware of the startups that have disrupted their respective industries, perhaps more so in pre-pandemic times, but say, for example, Airbnb disrupting the hotel business, or Lyft and Uber disrupting the taxi business. These startups, of course, were able to launch their businesses in the cloud. They were, quote unquote, born in the cloud, let's say, and take advantage of a lot of the benefits that the cloud offers. And by building their applications in a cloud native manner, we're able to deliver new features and innovations faster to market than the competitors. And of course, as we've seen the success of businesses like those startups just kind of grow immensely, we're seeing organizations across the entire spectrum starting to adopt not just the cloud as hosting infrastructure, but also cloud native development patterns, again, to reap those benefits of being able to bring features to market faster, scale more easily, and so on. And then again, I'll get into some of those more specifics in a minute. But first, let's talk about some of the stats behind cloud native. This comes from a report that's a little bit old at this point, but I'm sure the numbers are even greater now. I would say that the primary driver to cloud native, again, is enabling that faster time to market. And 2 years ago, 60% of companies have made cloud native the default when they design, build, and deploy their applications. And I'm sure, at this point, the number is probably close to 80%. So this is something that's seeing, widespread adoption across the board. And it's not something that is relegated or limited to just those startups. I would say you're seeing traditional enterprises, say like Chick-fil-A or Domino, who I would actually consider more of a tech company these days, adopting cloud native development patterns, again, to bring more convenience to consumers and also to bring those features and new products to market faster. So containers, of course, are a technology that has seen rapid adoption over the past few years, and is something that is seen as kind of vital or key component to cloud native applications. And here's some stats from a survey done last year, showing that containers are moving from development to production. 75% of organizations surveyed already using containers for production applications, with 27% planning to do so in the next 12 months, with only 3% saying that they're not interested. So this is a pretty significant statistic in the sense that this is a good indicator of just the adoption of containers and also the cloud native development patterns that kind of relate to the use of containers. So let's talk about these cloud native development patterns. So this is a point that I imagine is probably pretty well understood amongst this audience, but just as a review, cloud hosted, of course, is not always cloud native. There is the idea of lift and shift, is where you're taking your existing on-premise applications and moving them to the cloud, perhaps because the organization no longer wants to manage their own data center, or perhaps gain some of the benefits of having applications hosted in the cloud, such as just better security out of the box. However, the lift and shift approach carries with it some of the same flaws as on-premise. So, for example, no auto scaling. You still have to maintain your servers or VMs and patch them, etc. And the analogy here would be as if Netflix just put some DVD players in a AWS data center and called it a day. Versus cloud native, which is redesigning or rebuilding your application to take advantage of cloud services. So a lot of times this means taking your monolithic application and breaking it down into microservices, which I'll be talking more about just a slide or two. Moving to cloud native or taking in an existing application that was previously hosted on premise and perhaps more of a monolith and turning it into a cloud native application can be complex and time consuming. However, there are substantial benefits in the long run. And the analogy here would be actual Netflix. So why go cloud native? There's a number of reasons, but I would say chief amongst them are, one, just reducing your operational costs of the infrastructure hosting your application. And a lot of that is due to the resource efficiency of containers, which I'll talk about more. You'll be able to bring features and applications to market faster, as I mentioned already. Better security. So for example, if you host an application or a workload in AWS, you by default get denial of service protection. Whereas if that application was hosted in your own data center, that's something that you would have to implement yourself. So there are just by nature of being hosted in the cloud, you can take advantage of some of the security controls that are just enabled by default. And then better extensibility. And this primarily relates to the use of microservices or a microservice-based architecture, where thanks to the modular nature of such architectures, it's easier to add on to. I mentioned containers as kind of as part of the pattern of cloud native development, but just as a review, what are containers? So containers are an application layer construct. They make it possible to package web applications along with all their required dependencies, libraries, and other binaries required to make the application run. And unlike virtual machines, distinct containers can run apps individually and share the same operating system kernel, making them much more lightweight than virtual machines, each of course requiring their own full operating system. So I'm going to quickly pass it over to Doug to just talk a bit about the progression in terms of how we got to cloud native and the use of containers and some of these other technologies that are used in cloud native development.
Yeah, thanks for that, Alfred. So it's been quite an interesting journey from kind of the historical presence when we were more of a servers and monolithic type applications. Those applications had very different release cycles than we're seeing in current environment, where before, you might be releasing quarterly, half year, or yearly updates. And if you need to update one component of an application, that generally meant that you had to update the whole application. So it was a lot more of an involved process and didn't necessarily lead itself well to an agile type development, since you were updating the whole thing as opposed to just components in one function. As we moved away from the traditional server approach that was an all-in-one, usually with everything mostly on the same server or a couple of physical servers, we started to move to a virtual machine kind of infrastructure with an n-tiered. And this is where we started to have more of a separation in what those systems were doing. So you definitely would have web servers and, say, database servers on different systems, but various components just in general were starting to move away from a one server approach to everything. It started to allow you to be able to have a slightly different approach to your development cycle and be able to focus on the different components that made up an overall application. It also allowed you to have a little bit more efficiency in how the density of your servers were being used. So there was definitely a cost savings in the actual hardware kit that you were maintaining. And then this kind of leads to the more current architecture, as Alfred was talking about, and especially cloud native. And that was moving to containers with microservices and enabled the agile and DevOps and nowadays the DevSecOps approach. So this gives you a lot more efficiency and density in the environment. You're using more of the resources that are available in that bare metal environment and able to be more agile. So when you start using microservices, you're starting to be able to have a function that does one task, and you could update that one function without potentially affecting the other ones that are running, and also have health checks and self-healing so that things can come back up and just be a lot more efficient in how you're actually maintaining that environment. So the containers and microservices is a pretty good increase in efficiency. And it's also been quite an interesting progression, because as people move from that monolithic applications, if they didn't originally design those applications as cloud native, it is a lot of, as Alfred mentioned, having to pull out functions and turn those into microservices, which leads to interesting challenges.
Cool, thanks, Doug. So we've spoken about efficiency and cost savings a few times now. An analogy that I like to use, and something that I used in my last talk over at DevOps.com last month, was that you could think of containers as kind of apartments in an apartment building versus a standalone home, which would be like a virtual machine. Both an apartment and a house could occupy the same amount of land. But you can, of course, pack a lot more families into apartment building because there are shared resources, things like a single roof for all of those dwellings, a single front entrance, utilities, etc. So similar to an apartment building, the use of containers allows you to pack more applications in the same amount of infrastructure or hardware, if you will, then you could, let's say, if all those applications are broken out into their own virtual machines. The caveat, though, of course, is by having these shared resources, some new security risks come into play. So, for example, if you live in an apartment, you may do a good job of securing your own apartment unit. However, who's to say if your neighbor down the hall is making copies of the key that accesses the front door to the building, and who knows who those keys are being shared with. So similarly with containers, because they do share, resources, those shared resources could become like an avenue of attack that could result in a compromise. So things like container breakout, for example. And this is just a visual just to show you how containers, since they can be packed more efficiently, provide that cost savings. And as a side note, Kubernetes, as I'm sure you're all aware, is the container orchestrator that is used to run containers in production. Allows you to auto-scale containers to meet demand, self-healing whenever containers fail, and so on. So let's talk in a little bit more detail about microservices. And the example here I like to use is like an e-commerce website, since that seems to be a type of web app that's fairly well understood. So let's say you have a monolith here on the left-hand side, has a shopping catalog, a shopping catalog for customers to view the inventory, a cart so that they could check out, purchase items, and reviews as well, so that they can leave their impressions of the products they've purchased. When you have all the services written in a monolith, they of course need to be written in the same language because they all go into the same code base. It can be difficult to work on different services in parallel, and this often led to what was called integration hell back when most development teams were working in a waterfall sort of approach. The interdependencies between the various services, because they all live in the same code base, can make it difficult to say create a new version of the reviews service, but because of interdependencies it has with, say, a catalog, when it comes time to merge the new review service into the code base, you encounter perhaps new bugs, new issues, delaying release. The full application, when it comes to a monolith, the full application needs to be redeployed with every update, which can cause unnecessary downtimes for services that haven't changed in the latest update. Scaling, of course, requires replicating the entire application, which can lead to waste or unnecessary hosting costs. So let's say your e-commerce site is experiencing a huge influx of traffic because it's Cyber Monday, and you have to scale up the catalog to meet the demand. With a monolith, you would have to replicate the entire application in order to meet that increased demand just for the catalog service, meaning that you're consuming resources to host additional instances of your shopping cart and reviews, even though in your review service, even though those services may not be seeing as high demand as the catalog. Now you compare that against microservices. So with microservices, these services can be written in different languages, providing development teams with more flexibility in how they actually implement the business logic for the service. It's easier to work on these services in parallel and add new services, as long as each of these services kind of adhere to the agreed upon spec or the API schema that's used to facilitate communication between the various services. There's just fewer interdependencies, and thus it's easier to work on them in parallel. You can deploy these services individually, which is helps to enable continuous deployment. So again, let's say if the catalog is being updated at a more rapid pace than, say, the shopping cart, you can use automation to continuously deploy or deliver that shopping catalog without impacting the cart. And you can scale services individually as well. So as you know, going back to that Cyber Monday example, big influx of demand for the shopping catalog, you can just scale that service while leaving the same capacity in place for the cart and reviews, and thus not creating any waste or using up unnecessary resources. So, so we're here, of course, today to talk about securing your cloud-native applications. And when it comes to layer 7 protection of applications, application layer protection, that typically means web application firewalls. And traditional web application firewalls have been around for some time, and they were first designed and developed prior to cloud native was ever a thing. And because of that, there are ways in which traditional WAFs just kind of fall short in terms of protecting cloud native applications, especially if they are using a microservices architecture. The first I would say is traditional WAFs weren't designed to keep up with the rapid rate of change of modern cloud native applications driven by CI/CD. When these traditional WAFs were first designed, applications were being updated at a much less frequent rate, maybe quarterly or annually. And oftentimes, whenever there was a change in the code, rule sets would have to be updated. When you're updating your application only a couple of times a year, that's something that's manageable. But if you're updating your application multiple times a day, and those changes could break existing rules, that often means the security team is busy having to constantly update the rule sets in order to keep up with the application teams. And naturally, that is very difficult to do if these application teams are pushing deployments multiple times a day. And what you end up with is a WAF that's never turned on into blocking mode, but left only in logging mode. And of course, when you're just in logging mode, you're not actually providing any protection to the application. These traditional WAFs are also not always container friendly, requiring a dedicated VM or a bare metal appliance to operate, which means they're less resource efficient. You don't get some of those benefits of running these kinds of technologies in a container. And they're also often deployed on the perimeter and blind to east-west attacks, which Doug will talk more about in the next section. Another point I like to make is something that I've discussed in last month's talk that I did over at DevOps.com. When you have a perimeter-based WAF, that usually means you will have a WAF that is kind of tied to your hosting environment and not to the application, which usually results in a kind of disjointed or fragmented sort of WAF rollout. So for example, let's say you have applications in a data center in AWS and in Google Cloud. You might be using a traditional sort of appliance-based WAF in your data center, AWS WAF for AWS apps, and then Google Cloud Armor for your GCP apps. And when you have three separate apps or three separate WAFs protecting apps across these three different hosting platforms, you have different rule sets, you have a different interface and feature sets for each of these WAFs, which ultimately means a disjointed WAF policy, making you less secure, making it harder for you to implement a policy organization-wide to protect your applications. With the next-gen WAF, though, which differs from a traditional WAF in that the protection is not tied to the hosting platform, but instead tied to the application itself. You can have WAF protection in different hosting environments with the same tool, which means a single rule set, single interface and feature set, and ultimately a unified WAF policy that's easier to implement and leaves you more secure. Okay, now we've come to security and visibility into EastWest Traffic with the next-gen WAF. So I talked about microservices earlier and some of the benefits. However, with microservices, not only do they create complexity, but they actually also can create some new security risks. And one of the ways that organizations today are helping to are securing their microservices-based applications is through the use of service mesh. So here I'm using Istio as an example. And Istio is a service mesh that helps to solve some of the issues I've listed here. So for example, load balancing, service-to-service traffic, ensuring communications between services is trusted or legitimate. So before, because these services may have lived in a monolith, all that communication was occurring within the same process or in the same application. Now that you've broken these out into microservices, that communication is, typically going over the network. So how do you ensure that these communications is trusted or legitimate? And with service mesh, they usually accomplish that through mutual TLS. How can I prevent one service from talking to another? So let's say, for example, there's no business logic reason for your shopping cart to talk to the review service. With the service mesh, you can create a policy where that channel of communication is just blocked. And by kind of segmenting your network or your microservices network in this way, you just ultimately decrease the surface area of attack, making it less easy for attackers, if they were to compromise one service, to move laterally and attack other services within the same cluster. They also provide benefits in terms of traceability, being able to see, okay, let's say you have multiple versions of the review service, being able to see which version of the service or instance of the service responded to a particular request. And then also canary testing. So let's say you have version 2 of your reviews here, as shown in the diagram. With the service mesh, you can incrementally move traffic over to the new version of that review service. So in this example, I've got 90% of traffic going to the first version and 10% going to version 2. And that way you can see if there are any issues before you roll out version 2 of the review service to all the traffic. Another way to think about service meshes is the snail mail analogy. So let's say you're not using a service mesh or you're not using a proxy, and you have two services, let's say Alfred and Doug. In the case where you don't have any proxy or a service mesh assisting or helping out with managing the intercluster traffic, all the networking is going to have to be handled in the application. And the analogy there would be as if I'm writing a letter to Doug, I would have to find out exactly where Doug is at the time I want to deliver that mail or that letter and hand it to him in person. With the cloud native proxy like Envoy, this is as if a mail route was established between, say, two cities, one where Doug is living and one where I'm living. I no longer need to hand Doug that letter personally, but instead just drop this letter in this route and eventually it'll get to Doug. With service mesh, the analogy then is, I would say, the United States Postal Service. So without knowing exactly which route that letter is going to take to get to Doug, I can just drop it in a mailbox, and the service mesh or the Postal Service would make sure that the most efficient route is taken to get that letter over to Doug. So at this point, I'm going to hand it over to Doug to talk a bit more about some of the challenges with microservices and how you can address them with the next-gen web application firewall.
Yep, thanks for that, Alfred. So there's always some assumptions of microservices that I've noticed. The key one, and this is always an interesting one, is the assumption that internal microservices will actually be just internal. And so they usually are designed that way. And because of that, that means they generally will have a different consideration of what security levels they actually need. So authentication of the service itself, do you have access to access that server? Should they be accessing something upstream? And there's just a very different mindset of an internal microservice than there is something that is supposed to be external. So that can lead to different challenges. And generally, there's also an assumption that the traffic between the individual microservices that make up an application or whatever infrastructure it might be is going to be legitimate and actually should be the right traffic. And that because it's internal, it definitely is going to be legitimate. So as we move on to the next slide. There we go. This was an interesting blurb that I found from the Cisco side, actually. And it's talking about with things being highly distributed, the numbers I found very interesting was that now there's 70 to 80% of the traffic being east-west traffic as opposed to the normal north-south traffic. A lot of this is because the microservices, they might be the same data center or different ones, are having to do this communication internally between each other as opposed to being all within the same monolithic application. And the historical traditional waterfall approach, a lot of the things that are now network communications used to be just intercommunication within one application. As we shift that kind of pipeline to the microservices approach, this means now obviously we have a lot more communication between services that never existed in the past, and also just leads to different trends in how we process that information, how we secure it, and how we protect it. So what that might look like. And what we have here is we have what is our new perimeter effectively. This is the ingress and now is the software perimeter. Historically, that perimeter, when we talked about it, was at the network layer where you had your traditional routers and load balancers always being at the end. But now we have new ingresses or new ways of having what that perimeter is. So in this case, an ingress might be Envoy, as mentioned by Alfred, or it could be Nginx, or it could be a whole bunch of different types of ingress controllers. into, in this case, a Kubernetes environment. And there's ways that you can protect the ingress layer. Additionally, behind there, you then have your microservices. And now you have the types of installs like RAS that might be the code layer. This could be a Node.js server, it could be a Java server, or it could even be other types like Apache or Tomcat or whatever it may be, but something at the container layer. And then we also have a few other types of installs. So we have the service mesh, as mentioned with the Istio, and there's a couple others out there. And we also have other things that can still sit in front of this. So you might have a reverse proxy in front of the whole cluster. You might have Cloud WAF, and some of these are used both for the cloud infrastructures like Kubernetes, but also for the traditional perimeter-based, on-premise-based approaches. So there's a lot of different ways that you might need to set up and be configured within your environment in order to actually be able to protect both your cloud native applications, and you still want to, of course, protect your historical on-premise applications in a consistent way across all of them. So let's talk about, and this is actually, although it's saying detection and protection at the ingress, it talks about some of the pros and cons of that and why you might want to protect at the ingress and why you might want to protect at the actual microservice layer, and maybe even do a portion of both. So one of the good things about when you are looking at the ingress layer is the fact that you're looking at the consolidated traffic. This means that you're seeing all traffic from the north-south before it comes into your environment, and you have a lot of control over what's going on. It makes it easier for your app teams who are deploying those microservices behind the ingress. They don't need to worry about setting up the security and protection. That's the responsibility of the people who are controlling the ingress, and it makes it much easier from that approach. It also is very simple generally to configure because you can set up a policy there at the ingress layer and not really have to worry about setting a whole bunch of different policies because it's just one for that consolidated approach. Another very valuable portion is the fact that you're actually protecting before it gets to your microservices. One of the efficiencies of the microservices is that you only scale up the components that you need. But if you have somebody doing a DDoS or some kind of attack against your infrastructure that's not necessarily legitimate traffic, this means you can block at the ingress controller before it gets to the microservices behind it and avoid having to scale out those individual microservices. So this is all great, but it does also lead to some challenges or some cons. And one of those is if you're only at the ingress layer, if one of the microservices that are sitting behind it gets compromised, something has gotten through in some way, shape, or form, and it's compromised, especially things like command execution, this means that you're not detecting traffic of that inter-microservice communication, the east-west type traffic. Additionally, it's harder to actually set up rules and policies per application or microservice. If you're at the consolidated approach, you might have a particular application that's somewhat different than the others and don't necessarily work under a general policy. So they might want to be handled or maintained differently. Or as you're bringing on new applications, not necessarily having it behind some kind of protection, as you want to make sure that it first works before you do. So it's a little bit harder to manage those because it's going to be enabled for all of those microservices. Also, from a reporting perspective, it's a lot harder to break out metrics on a per app or microservice layer than it is when it is actually installed at those microservices. So there's value and cons to both, and it really just depends on what's required for your environment. I've seen customers with Kubernetes environments where they have one namespace be one microservice. And in that kind of case, yeah, putting it at the ingress controller probably doesn't make any difference than putting it at the app layer because that one namespace is for that one microservice. Others might have tens or hundreds of microservices in one namespace. And then there could be pros and cons. And I've seen customers in the past only protect the ingress or only protect at the container level or protect at both. It's really a matter of what makes sense for an individual customer's environment. and really what kind of level of detail and control that you need in place. But the main kind of caveat is across all of those environments, being able to do that in a consistent fashion.
Cool. Thanks, Doug. So what did we cover today? So first, cloud hosted, of course, does not mean cloud native. Cloud native is a design or development pattern that typically requires or includes the use of containers, optionally service meshes, microservices architecture, CI/CD, and so on. A perimeter-based traditional WAF is outdated with cloud native. So perimeter-based traditional WAFs, of course, will not provide you with the level of flexibility to deploy at, say, the software perimeter at your Kubernetes ingress, or within the service mesh itself, or perhaps on the workload itself. Whereas the next generation WAF will be able to provide you with that flexibility and allow you to kind of create the protection that makes the most sense for your application. Service mesh can provide benefits to microservices architecture apps. So there's a lot of new networking complexities and challenges that result from a microservices architecture that service mesh can help you solve. However, service mesh on its own does add an additional layer of complexity. So I would say, definitely get comfortable with Kubernetes first before embarking on service mesh. Next generation WAF provides multiple options for where layer 7 protection can be deployed for a cloud native. So again, going back to that diagram, whoops, where did that go?
I think your actual browser with the slides crashed.
Okay, I'll be all right. Let me launch it.
It was the last slide anyways, wasn't it?
I
think it was. I wanted to go back to that diagram.
Well, while you guys are doing that, I just want to remind the audience that you can go ahead and submit any questions you might have using the GoToWebinar control panel. And then as soon as we get to the question and answer period, we can go ahead and dive right on into those.
Okay, sorry about that. Just bringing it back up.
Technology is a fun thing sometimes, huh?
Yeah, it's great when it works.
Exactly.
Okay. So the point I was making was that with the next generation WAF, it provides you with the ability to deploy in a number of different places, whether that is the ingress to your Kubernetes cluster, say via an integration with whatever ingress controller you may be using, whether that's Istio ingress or Kong or HA proxy or Nginx. Deployed on the workload itself in kind of like a RASP style deployment or runtime application self-protection, or in the service mesh. So our next gen WAF has an integration with Envoy that allows us to be deployed alongside the Istio sidecars throughout your service mesh, or as a reverse proxy to protect your legacy applications in your data center, and kind of more of a traditional perimeter-based deployment. So the final point there is that there are pros and cons, as Doug was mentioning a little bit ago, as to where you deploy that protection. So what makes the most sense is going to be based on kind of what your goals are in terms of protecting your application and kind of how your application is architectured. So with that, thank you for tuning in. I guess we'll move on to the Q&A section now.
All right, great. So yeah, guys, we have about 10, 12 minutes or so to go through audience questions. So if you do have a question for either Doug or Alfred, please go ahead and use your GoToWebinar control panel. and we will try to get to as many as we can. Okay, the first one here is, let's see. Okay, so here you go. In your talk, you mentioned quite a bit about the need for protecting east-west traffic. Could you give an example of a threat or an attack that takes advantage of an east-west security vulnerability?
Sure, I'll take this one. So I'd say server-side request forgery is probably a good place to start. So if you're familiar with the Capital One breach that happened a number of months ago, that was an attack that was designed not necessarily to compromise the application itself, but rather gain access to an AWS metadata service through a server-side request forgery. So essentially, code was, or there was a command that was injected into a request sent to an application that was then passed on to the AWS metadata service, which allowed the attacker to gain information such as like roles and credentials or keys to gain access to the AWS account that was hosting that application. So this was an attack that wasn't necessarily targeting the service that was external to the internet or accessible to the internet, but rather a service that was kind of one or two steps removed from that external traffic.
All right, great. So next question here. How do you ensure security in containers?
Yep, so I'll take that one. And Alfred, feel free to chime in. I would say there's a few different things when we talk about security containers. We've been talking about our focus of the layer 7 protection, which is very important. So you want to be able to protect, especially this communication. Most of the microservices tend to do communication with some kind of HTTP-based form, whether that's doing a REST API, or nowadays I've seen a lot of things be HTTP2 with gRPC. So being able to protect that from traditional web-based attacks, and also from being able to do business logic attacks, and from these kind of ones like the Alfred just mentioned about seeing what kind of API services are available and extracting that information when you're looking to see what's in that environment. There's also the more kind of hands-on of the container itself that other companies out there like Aqua and Twistlock focus on. And that tends to be, are you doing the right kind of configuration and policies? And starting from the Docker file when you go to build things, are you running as root, or are you running as another user? OpenShift does a good job of this out of the box, which will be that even if you haven't configured things, will automatically set things to run as a different user so that it's not running as super user. So that's definitely a very important part. Another part is ensuring that where you're actually pulling your sources from are either from a verified source or something that you're actually creating yourself, to ensure that what's going into the container is what you expect it to be. I know a lot of people out there tend to just use sources that they find online, but I always recommend actually verifying that source when you're setting up that from, and how that container is being built, to ensure that it is actually as expected and nothing is malicious has gone in from the very get-go. So how that actually runs, also, I would say just verifying and making sure that you've actually ensured that an internal service isn't exposed externally. And then there is also just how the app itself is written. So we talked about, especially for services that have broken out from a monolithic to a microservice-based approach, if that is the case for something that you're actually writing for a function, have you thought about the correct level of authentication and access control that that microservice should have? So even if it's internal, how do you authenticate to it? And how do you verify what upstream data that it's pulling it should, and limiting the scope to exactly to only what that function needs, as opposed to a wider scope? So there's a few different topics there, but those are generally the things I think of when ensuring the security of the container. And they stream from the layer 7 all the way to how you build the Docker file and your actual app yourself.
Excellent. Alfred, do you want to jump in on this one, or shall we just move on?
Yeah, I'd say that was a great overview. The only thing I would add is that a lot of the kind of container breakouts or container-based attacks tend to start with the application layer. So whether that is some sort of command injection or server-side request forgery, what we've seen is that although you may have controls on the container itself, perhaps with like an Aqua or a twist lock, it's oftentimes that layer 7 application layer attack, which kind of kicks off that exploit. But you for sure want to assess your containers in pre-production, make sure that you're aware of the vulnerabilities that might exist in all the layers of your containers. And there are plenty of solutions out there to do that.
All right, great. So we're about 9 minutes to the top of the hour. I think we have time for 2, maybe 3 more questions. Here's one that just came in. What differentiates north-south traffic from west-east traffic?
Sure, I'll take this one. This is pretty straightforward. So north-south traffic is traffic coming into your application externally. So basically traffic coming from clients that are hitting your web application. East-west traffic is service-to-service traffic. So that's traffic that typically occurs like within the cluster or behind the firewall.
All right, great. Let's see, next question here. What makes cloud native better security over cloud hosted?
Sure, so with cloud native security, so see if I understand the question. So with a cloud native application, there's going to be kind of additional challenges than say protecting an application that was just lifted and shifted. So if you're taking an application, perhaps that's just a monolith that was previously hosted on-premise and moving it to the cloud, then you may not necessarily need to deal with all the microservice specific security risks that can come with a cloud native application. At the same time, though, with a lift and shift approach, you're not going to be able to realize some of the benefits of a cloud native application, such as, like I said previously, being able to work on services in parallel, get new features to market more quickly, and so on. So with the cloud native application protection solution, you'll be able to realize those benefits, but at the same time, do so securely by providing visibility and security into your east-west traffic, whether that is by deploying a next generation web application firewall directly on your workloads, or perhaps leveraging an integration with a service mesh.
All right, great. I think we have time for one more question here before we shut things down. Let's see. Can I use your product to see attacks against all hosting platforms in one place?
Yes, that's definitely one of the benefits of a next generation web application firewall. Since next gen WAFs are built to be deployed on applications, or rather they are designed to be tied to an application or a workload rather than a hosting environment. You can deploy Signal Sciences pretty much wherever your application is hosted. So whether that's your on-premise data center, AWS, Google Cloud, Azure, and so on. And like I had in my presentation, that slide that showed the different WAFs kind of being segmented across the different hosting platforms, leading to a disjointed WAF policy versus a single WAF that can be deployed in multiple hosting environments that will help you to realize a unified WAF policy.
Excellent. Okay. All right. Great. Well, it looks like that is all the time that we have for the question and answer period today, but I do want to thank everybody who did submit questions. If we didn't get to your question, I apologize, but please know that the folks at Signal Sciences will be getting a copy of all of the questions, so I'm sure they'll be more than happy to follow up with you offline to get your question answered and any other questions you might have. Okay, also want to remind the audience real quick that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinar and look in the on-demand section, and it should be right there waiting for you. Okay, before we sign off for the day, I do want to do the drawing for the $250 Amazon gift cards. So without further ado, let me get right to that. Our first winner today is Devon with an A-N-A. Congratulations, Devon. And our second winner is Kim with 2 M's, Y. Congratulations, Kim. We're going to follow up with the both of you via email offline, so please check your inbox for that, and we'll get your get your gift card right over to you. Okay, guys. Doug, Alfred, thank you very much for a great presentation, lots of good information, and judging from the number of questions we got from the audience, I know that they enjoyed it as well. So thanks so much. I really appreciate it.
Thank you for having us.
Thank you.
All right, and I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.